Everyone. Today we're starting a new chapter, chapter 13, which will cover alcohols, phenols, and ethers. And we'll go over what those are in a second. But just some examples of alcohols. Down below we have isopropyl rubbing alcohol, which can be used to clean wounds and cuts. Up above we have a martini glass here. So in alcoholic beverages, those contain alcohol, ethanol in particular. And then down below we have cholesterol, which is a health risk if you have too much cholesterol. But most of the atoms in cholesterol are carbons and hydrogens, shown by the black and white atoms. But down in the bottom corner, you can see a red atom. This is representing oxygen. And then the white atom that's attached is hydrogen. So this is an OH group, which is our alcohol group. So alcohols are really present in a lot of different solutions that we use day to day. They're also present in many of the molecules in our bodies. So alcohols, phenols, and ethers are important organic compounds that do occur naturally, either, out in nature or in our own bodies, but we can also produce them synthetically in significant amounts if we need to for different purposes. So one example of the production of ethanol is fermentation. So for instance, there is a fun lab you can do where you add some yeast to some molasses. And over time, the molasses goes through a fermentation process using the enzymes, so the catalysts from yeast, and you end up producing ethanol. Now, of course, you'll want to purify that ethanol, but it's a really fun experiment. Menthol, which is another alcohol, is obtained from peppermint oil. So you can use distillation to produce menthol. And this can be used as a flavoring agent. And again, cholesterol has been implicated in some forms of heart disease, so you don't want to have too much cholesterol. And again, there's an alcohol group on that cholesterol molecule. So again, these are present or alcohols at least, are present in a lot of different molecules, naturally or synthetically. And here are the structures for those different molecules we just talked about. So ethanol is a really simple molecule. It has 2 carbons, 6 hydrogens, and 1 oxygen. And again, note the OH group on the very end there. Menthol is a bit more complex. It has a cyclohexane ring. So that's our 6-membered ring in the middle there. And then it has a methyl group on top, our alcohol group kind of down to the right, and an isopropyl group on the very bottom. But what's nice is we can just simplify that whole thing and call it menthol instead of having to name each of the different groups that are attached. And then finally, off to the right, we have cholesterol. So this is the kind of condensed structure of cholesterol. And again, note the OH group down on the bottom left. Now, you don't have to know these structures. I'm just showing examples of how each of these have an OH group attached. So they are alcohols. So just as review, a hydroxy group is the OH functional group. And an alcohol has an OH group attached to an aliphatic carbon. So the general formula is ROH, where R is an aliphatic carbon group. So that would be something like ethanol, where we had CH3, CH2OH. So the CH3, CH2, we can just replace with R to indicate that we have some sort of alkyl group attached to the OH group. Now we say aliphatic here because we want to make sure that we're differentiating between an alcohol and a phenol. So a phenol has an OH group on a benzene ring. So remember, aromatic compounds have alternating double bonds. Aliphatic compounds don't have alternating double bonds. So, aliphatic just means non-aromatic, essentially. Okay, now if you do have a benzene ring present with an OH group attached, again, that is a phenol. So we can see our benzene ring here, and it's attached to an OH group. So we'll talk more about phenols later on. And then finally, in this chapter, we're also going to cover ethers. And ethers have an oxygen in between two carbon groups. So remember, up above, we could replace the carbon group with R. So we can do the same thing here just to kind of generalize what an ether is. So again, we have an oxygen in between one carbon group and another carbon group. And the apostrophe on the second R just indicates that that carbon group could be different. You might not have a symmetrical molecule. It could be asymmetrical. All right, so let's talk about how to name alcohols. So this is pretty similar to how we would name alkanes or alkenes, for example. So you're going to name the longest chain to which the OH group is attached, and then you're going to use the regular hydrocarbon name or alkane name of the chain, and then drop the final E and replace it with OL. So as an example, let's look down below. We can see that the carbon chain has already been numbered for us. So there are 6 carbons in that chain. So normally, if this were an alkane, we would name this hexane. But because we have an alcohol group attached to that chain, we're going to drop the E and replace it with OL. So that's what makes it, or indicates to us that we have an alcohol. Then in step 2, we're going to number the chain so that the OH group has the lowest number possible. So again, very similar to how we would treat any group attached to our longest chain of carbons. So again, the chain has already been numbered for us, so we can see the OH group is on carbon 3. If we had numbered this from left to right, the OH group would have been on carbon 4, and we know that we can get a lower number by numbering right to left. So then we just add that 3 in front to tell us where the alcohol group is located. Okay. Now, if you have more groups attached to your longest chain, then in step 4, you're going to locate and name any other groups attached to that longest chain. Then in step 5, you're going to combine the name and location of other groups, the location of the OH group, and the longest chain into one final name. So down below, we have, again, hexanol, and again, the OH group is attached to carbon 3, but now we have 2 methyl groups that are attached to carbon 4 and carbon 2. So we're going to add 2,4-dimethyl in front of 3-hexanol. So not too bad. Now, if you do have multiple groups, you do want to prioritize the OH group. So the OH group should get the lowest number that it can have. So if you're trying to decide between, let's say, do I give the lowest number to methyl or to OH? You're going to try to give the lowest number to OH. Now here we didn't have much of a choice because there were methyl groups on either side of that OH. So the OH group had to be on carbon 3. But if you had to choose, you would prioritize OH. And I'll go over an example of that in a second. Now, what if you had 2 alcohol groups on your chain? Well, this would be called a diol, And these are actually fairly common. If you have three OH groups on your longest chain, then that would be called a triol. So this is very similar to when we talked about how to name alkenes. If you have two double bonds, it's a diene. If you have three double bonds, it's a triene. So same thing here, we're just using the OL ending instead. Okay, so then if you're naming something with two OH groups, then at the very end, instead of using OL, you would use diol or triol, depending on how many alcohol groups you have. Okay, so let's do some practice problems. So I'm going to give you a few alcohols, and I would like you to try to name them on your own first. And then you can pause the video while you do that. And when you're done, we'll go over them together. So let's look at the first example. All right, there's example 1. And below that, I will put our second example. And below that, we've got our last example. Okay, so again, when you're done, unpause the video and we'll go over it together. Okay, so let's start with the first one. So we want to figure out our longest carbon chain. So actually, let me highlight the longest chain. So it looks like our longest chain has 1, 2, 3, 4 carbons in it. And then the OH group is just on the very end. So we want to make sure to number this so that the OH group has the lowest number possible. So I'm going to number from right to left. Okay, so that means the OH group is on carbon 1. So if we have 4 carbons total, how would we name that chain? What prefix would we use? So normally we would call this butane, right? But we're going to drop the E and add OL so that it's butanol. And then we want to put a 1 in front just to indicate where the OH group is located. Now we also have this methyl group sitting up above, and that is on carbon 2. So this is 2-methyl 1-butanol. Okay, let's go to the next one. So this one has a ring structure in it. So we want to name that ring structure because that will be our quote-unquote parent chain or longest chain. So this ring structure has 1, 2, 3, 4, 5, 6 carbons in it. So what would we call that ring? So normally we would call that cyclohexane, but because we have an alcohol attached, we're going to call it cyclohexanol. So we dropped the E and added OL. And then we're going to give that alcohol the first position on the ring, so position 1. Because the OH group is going to get priority in this case. And then let's see, if we look at our other group that's attached, what is that group called? A nitro group. Okay, so we want to number the ring so that the nitro group has the lowest number possible next to the alcohol, of course. So we'll just number this going clockwise, and then the nitro group will be on carbon 3. So 3-nitro-1-cyclohexanol. Okay, so now for our last example, we have, let's see, our longest carbon chain. And it looks like there's 1, 2, 3, 4, 5 carbons in that chain. So normally we would call that pentane, right? But because there's an alcohol attached, we're going to call this pentanol. Now, this is where it can get tricky because notice we have a chlorine and an OH group attached. So we're going to prioritize the alcohol. So we want to make sure the alcohol has the lowest number possible, and then the chlorine will just kind of follow from there. So I'm going to number from right to left so that the alcohol group gets the lowest number possible. Okay, so the alcohol group is at position 2, so we'll add a 2 dash in front of pentanol. And then we'll add where the chlorine is located. So that's on carbon 4, so that's 4-chloro-2-pentanol. So 4-chloro-2-pentanol. Okay, so hopefully that helps a little bit with kind of understanding how to name alcohols. Let's also just briefly go over how to name phenols, since they are pretty closely related. So substituted phenols are usually named as derivatives of the parent compound phenol. So this is really similar to when we were naming benzene derivatives. We always used the name benzene at the end, unless it had a common name like toluene or aniline. So here, phenol is one of our common names. So if you see a benzene ring with an alcohol group attached, you can just use the name phenol. So in the middle, we have another example where we've got our phenol parent compound, and then bromine is attached directly opposite the alcohol group. So again, the alcohol group would get position 1, and then we just go around the ring, and then bromine is at position 4. So we would call this 4-bromophenol. And then in our last example, again, we have our phenol parent compound, and then we have 3 bromines attached. Now, we want to make sure the OH group is at position 1 because it's just understood that in the molecule phenol, OH is at position 1. And then we'll just number around the ring. Doesn't really matter which way we go since the molecule is symmetrical. So it looks like the bromine groups are bonded at carbons 2, 4, and 6. And then we want to make sure to indicate we have 3 bromines, so we're going to add the prefix tri in front of bromo. Okay, so let's do a couple of example problems. So I'm going to give you 2 compounds to name, and I would like you to try them on your own first. So you can pause the video, and then when you're done, we'll go over them together. Okay, all right, so I'll see you in a minute or two. Okay, let's try to name the first one on the top. So again, we know that we have phenol because we can see that OH group attached to benzene. So that's automatically going to be at position 1, right? So we can just write phenol to start. And then we have a chlorine group attached. And we want to make sure to number the ring so that chlorine has the next lowest number possible. So we're just going to number it clockwise so that chlorine is at position 2. So this is 2-chlorophenol. Okay, let's look at the example below that. So again, we've got phenol here. That's our parent compound. And then we have 2 nitro groups attached. And we want to make sure to number the ring so that those have the lowest numbers possible. Although this molecule is symmetrical, we could draw a line down the middle. So it doesn't really matter whether we number this clockwise or counterclockwise. Um, the nitro groups will still have the same carbon numbers. So let's just go clockwise, make it easy here. Okay, so it looks like the nitro groups are on positions 3 and 5. So we'll write 3, comma 5 dash, and then don't forget the prefix di in front of nitro. Oh, and there shouldn't be a space in between the groups, so I'll just rewrite phenol here because it looks like there's a space, but this is actually all one word. There we go. It's just hard to write backwards, I guess. Okay, so hopefully that's not too bad to remember when you have to name things. I'll also post a worksheet that goes over some naming with these types of molecules so you can get some more practice on the side. Next time, we're going to talk about how to classify alcohols. We'll also talk about some physical properties of alcohols as well. And then we'll go from there. Eventually, we'll talk about ethers and some other molecules too. So I'll see you then.